Hello everyone. Today we are going to start a new chapter. The name of the new chapter is logarithm. So logarithm is a reverse process of exponents. So let us understand the basic definition of logarithm first of all. So definition of logarithm. Let us assume there was a number a raised to the power b and our value is c. A raised to the power b and our value is c. In that case, we can say log of c to the base a is equal to b. So originally the base was a. The power was b. And the result is c. In logarithm, the base is again a, but the term c is called argument. The argument is b, and the argument is c, and the result is b. Now let's understand this using a proper example. First of all, logarithm of base raised of an argument will give us the power which is created. So let's take a simple example. Let us assume we have 2 raised to the power 3 is equal to 8. This means we can write log of 8 to the base 2 should be equal to 3. All right. Now, this is the basic meaning of logarithm. First of all, a logarithm is defined only at specific conditions. So there are some conditions for logarithm. So what are the conditions for logarithm? Let us assume we have log of an argument to a specific base. So the first condition would be that the argument of logarithm needs to be positive. Meaning argument is greater than 0. All numbers which are greater than 0 are positive. The second condition is that the base also needs to be positive. So base should be greater than 0. And the third condition is that the base should not be equal to 1. So powers are defined for a lot of cases, but logarithm is only defined for cases in which all these 3 conditions are satisfied. Now, let's take a few examples. Let us assume the question says, evaluate the following expression. Evaluate the following expression. I'm going to use the definition of logarithm. So the question specifies using definition of logarithm. So first point, the first question is log of 16 base 2. The second is log of 64 base 32. The third is log of 27 base 3 root 3. So let us calculate both the examples. For the first point, we have log of 16 to the base 2. Let us assume this value is equal to x. Let's assume the value is x. So by definition, 2 raised to the power x, this x should be the power, is equal to 16, which is the argument. So now we have to solve 2 raised to the power x equal to 16. This means 2 raised to the power x is equal to 16 is 2 raised to the power 4. Since the bases are equal, in that case, we can say x is equal to 4. Now, let's consider the second question. The second question says log of 64 to the base 32. Let us assume the value of this expression is x. Let us assume the value of this expression is x. In that case, 32 raised to the power x should be equal to 64. Now, we have to convert both of them to the same power of the same base. So let's try. 32 is 2 raised to the power 5 and we have whole power x. 64 is 2 raised to the power 6. This means 2 raised to the power 5x is equal to 2 raised to the power 6. Now we have to equate the powers because the base are already equal. So we can say 5x is equal to 6 implies that x is equal to 6 upon 5. So the answer for the second question is x value is 6 upon 5. Now let's start with the third question. The third question said log of 27 with the base 3 root 3. Now let's start. Let us assume the value of this is x. In that case, 3 root 3 whole raised to the power x is equal to 27. Let's simplify both of them. So root 3 is 3 raised to the power half. Whole power x is equal to 27. It is equal to 3 raised to the power 3. So 3 raised to the power 1 plus 1 by 2 whole power x should be equal to 3 raised to the power 3. This implies 3 raised to the power 3x by 2 is equal to 3 raised to the power 3. So let us compare the two powers. So 3x by 2 is equal to 3. This implies x is equal to 2 by 3 into 3. So we have 3 and 3 cancelling out and we get the result 2. So x is equal to 2. These are some questions from the very basic definition of logarithm. Now let's do another question. The question says, find the value of x, find the value or values of x for which given expression is defined. Given expression is defined. All right, so let's start. The first question is log x minus 5 upon 16 minus x. The second question is log x square minus 3x plus 2 base 10. So let's start both of them. For the first one, we have 3 conditions for log to be defined. First of all, we have 3 conditions for log to be defined. So the 3 conditions are the 3 conditions for log to be defined are follows. So the first condition is that the argument needs to be positive. So argument should be greater than 0. The second condition is that the base needs to be positive. So base is greater than 0. And the third condition is that the base cannot be equal to 1. So let's check all of these 3. For the first question, we have log argument x minus 5 by 6 base 16 minus x. So argument should be positive. So 16 x minus 5 should be positive. This means x should be greater than 5. This is the first condition. Let's write this down as condition 1. Now the base should also be positive. So 16 minus x should be greater than 0. This means x is less than 16. All right. And the last condition is 16 minus x should not be equal to 1. This means x is not equal to 16 minus 1, meaning 15. This means we have three conditions. The first condition is x is greater than 5. Second condition is x is less than 16. And third condition is x is not equal to 50. So let's combine the three conditions into a single equation. So I'm drawing a number line. Let's assume this is a number line. We have relevant points as 5, 15, and 16. The first condition says x should be greater than 5, but 5 is not included. So x is greater than 5. So I'll select all points which are to the right of 5. The next condition says x is less than 16. So x is less than 16. So all numbers which are smaller than 16 are included. Now, the third condition says x cannot be equal to 15. So 15 needs to be excluded. All numbers are acceptable, but 15 needs to be excluded. So for our final answer, we will need this common portion. We would need this common portion. So the common portion is final answer. The final answer is x belongs to 5 to 15. This region is 5 to 15. This is the first common portion. Union, the second region is 15 to 16. Now let's check the second question. The second question says we have to check whether log to the base 10 x squared minus 3x plus 2 is defined. Whether this is defined. So let's check with the argument and the base. So the conditions were, apologies. So the conditions were argument is positive, base is positive, and base is not equal to 0. Now, as we can already see that the base is already a fixed number. So we can check that directly. So 10 is greater than 0. This is essentially always true. So we don't need to check it further. The second condition is the base should not be equal to 1. So 10 is not equal to 1. This is also always true. So there's no problem here. Now the last condition is argument should be positive. That means x squared minus 3x plus 2 is greater than 0. Now you have seen how to solve this in the chapter of inequalities. If you are confused, kindly revise that chapter. What we do is we are going to factorize this. Once we factorize this, we get the result x minus 1 into x minus 2 is greater than 0. So let's draw the number line. The relevant points are 1 and 2. Now, the rightmost portion would be positive. The neighboring portion is negative, and we have alternate plus minus regions. Since we need the positive value, since we need the greater than 0 value, so we can say x belongs to the positive regions, meaning x belongs to minus infinity, say 1, union to say infinity. Minus infinity to 1 and 2 to infinity are our results. Let's start with the next question. So this was based on the basics of logarithm. All right. Let's check a few other things. First of all, these questions are based on the very basic definition of logarithm, and using them for all questions is complicated. So we sometimes try and simplify using formula. So we have some formulae. For logarithm. We have some formulae for logarithm. So what are those formulae? The first formula is log of a1 multiplied by a2 to the base b. All right. This multiplication will change into addition. So we can say log of a1 to the base b plus log of a2 to the base b. The second says log of a1 upon a2 to the base b is equal to log of a1 base b minus log of a2 base b. So for the first rule, multiplication changed to plus addition. For the second rule, division changed to subtraction. Now for the third rule, if you have log base b of a raised to the power n, if you have a power on argument, this gets multiplied. So this will become n. The power gets converted into multiplication. So n multiplied by log a to the base b. However, if the power is in the base, so if we have log of a and base b raised to the power n, so the power is in the base. In that case, the power will be dividing the number. So the power reaches the denominator. So we get 1 by n log a base b. We get 1 by n log a base b. Now, there are some extensions of the formula of part 1 and 2. That is, let's consider log base b a1 raised to the power n1 multiplied by a2 raised to the power n2, a3 raised to the power n3 up to a lambda raised to the power n lambda. So I am combining formula number 1, 2, 3. First of all of these can be split into different terms. So we can say log of base b a1 raised to the power n1 plus log of base b a2 raised to the power n2 plus log of base b a3 raised to the power n3 plus up to log of base b a lambda raised to the power n lambda. Now, each of these powers can get converted into multiplication. So our result becomes n1 log a1 base b plus n2 log a2 base b up to n lambda log a lambda base b. Let's check the next type of question. So the next type of property is if we have log a1 a2 into a3 up to am upon b1 into b2 into b3 up to bn. So all the multiplications would get converted into plus. So log of a1 plus a2 plus a3 plus log a3 up to log an. And you have all the portion in the denominator will get converted into subtraction. So this becomes minus of log of b1, log of b2, log of b3 up to log of bn. All of these terms are getting subtracted from the first expression. Now, there are some more rules. The next rule is, this is called the base change theorem. The next rule is called the base change theorem. So what are the base change theorem? Let's say you have log a1 base b upon log a2 base b. This can get converted to log a1 base a2. So this is the base change theorem. The base in a way can get cancelled. All right. Now let's start a few more questions. So let's start a few questions using these properties. So I'm going to write the question. Simplify the following. Simplify the following using properties of logarithm. Using properties of logarithm. Properties of logarithm means the formulae that we wrote down for logarithm. So the first is log base 10 an argument of 1000. So let's see. This can be written as log base 10 and 1000 can be written as 10 raised to the power 3. Now, this 3 is in power, so this can get converted into multiplication. So you get 3 into log 10 to the base 10. Now, you have log 10 to the base 10. So we have to note, we will be introducing any small formula as and when we required it. So we will note that log of a number n1 to the same base n1 is always equal to 1. This is because n1 raised to the power 1 is also n1. So here argument and base are the same. So we can say 3 into 1 is equal to 3. Let's check the next question. The second question is log of 32 to the base 16. So this becomes log of 32 is 2 raised to the power 5 and 16 is 2 raised to the power 4. So the power of argument gets converted into multiplication. So 5 would be in numerator. The power of base goes to the denominator. So you get 5 by 4 log 2 base 2. Once again, log n1 base n1 is 1. So you can say 5 by 4 into 1 is equal to 5 by 4. Let's try another question. The question says, you have to simplify log base 3 of log base 3 of 27 whole cube. Now let's start. So this becomes log base 3 bracket open, log base 3 bracket open. 27 can be written as 3 raised to the power 3 bracket close and whole power 3, and you have another bracket closed. Now a raised to the power m whole raised to the power n. This becomes a raised to the power mn. So this changes to log base 3 of log base 3, 3 raised to the power 9. Now, this 9 is can get converted into the product. So this power gets converted into multiplication. So you get log base 3, 9 times log of 3 base of 3. So this becomes log base 3, 9 times log of 3 base 3 would be 1. Now, log of base 3 and 9 is 3 square. This 2 can be converted to multiplication. So you get 2 times log 3 base 3. This is equal to 2 into 1 is equal to 2. So these are a few basic questions. Let's start a few basic examples. So I'll go for the last question now. The question says, let a is equal to log 16 base half, b is equal to log of base 3 tan of 30 degree, c is equal to log of 2 minus root 3 argument of 2 plus root 3, and d is equal to log of base 2 tan of 30 degree, c is equal to log of 2 minus root 3 argument of 2 plus root 3, and d is equal to log of base 2 tan of 30 degree, c is equal to log of base 2 minus root 3 argument of 2 plus root 3, and d is equal to log of base 2 argument log of base 2 of 4. Then we need to find out the value of a plus b plus c plus d equal to question mark. And we have four options. The first option is minus 7 by 2. The second option is minus 9 by 2. The third option is minus 5 by 2. The fourth option is minus 4. Let's start. First of all, a is equal to log of 16 base 1 by 2. So this becomes log of 16 can be written as 2 raised to the power 4. But 1 by 2 can be written as 2 raised to the power minus 1. This is because 1 by a raised to the power 1. This becomes a raised to the power minus m. So we get 2 raised to the power minus 1. So now let's convert the powers. So the power in argument will get converted into multiplication. The power in base will get converted to division, and you get 4 upon minus 1 log 2 base 2. Now log 2 base 2 would be 1, and you get 4 upon minus 1 into 1 is equal to minus 4. Now let's see the value of b. So b would be log of base 3 tan 30 degree. So this becomes log of base 3 tan 30 degree would be 1 upon root 3. So log of base 3, root 3 can be written as 3 raised to the power 1 by 2. So this becomes log of base 3. Reciprocal gets us negative power. So we get 3 raised to the power minus 1 by 2. Now, the power of minus 1 by 2 gets converted into multiplication. So you get minus 1 by 2 log of 3 base of 3. So we get minus 1 by 2 into 1 is equal to minus 1 by 2. Now, let's try and find the value of c. So c is log of 2 minus root 3, 2 plus root 3. Now for this we need an observation. For this we need an observation. If I say this is equal to log of some number n1 base n2, then n1 would be 2 plus root 3 and n2 would be 2 minus root 3. But the observation is, if you multiply n1 into n2, then we get 2 plus root 3 into 2 minus root 3. So a plus b into a minus b would be equal to a square minus b square. So this becomes 2 square minus root 3 ka square. 2 square is 4, root 3 ka square is 3. So you get the result as 1. So ultimately n1 into n2 is 1. So n2 is equal to, n1 is equal to 1 by n2. That means this is equal to n2 raised to the power minus 1. So c is equal to log n1 base n2 is equal to log of base n2. Argument becomes n2 raised to the power minus 1. So the power will get converted into multiplication. So you get minus 1 log n2 base n2. Log n2 base n2 is 1. So we get minus 1 into 1 equal to minus 1. Now let's check the last question, last portion. So the value of d should be log of base 2 of log of base 2 of 4. So you get log of base 2, argument log of base 2. 4 can be written as 2 raised to the power 2. So this 2, which is in power, will get converted into multiplication. So you get log base 2. Argument has 2 times log 2 base 2. Now, log 2 base 2 is always 1. So you get log base 2 and argument is 2. All right. So log base 2 argument 2 is 1. So we get the values of a, b, c and d. So a plus b plus c plus d is equal to -4, A is -4, B is -half, C is -1, and D is +1. So this value becomes -9/2. This is all for today's demo lecture. Thank you very much.